Okay, let's start. Share meeting. Okay. So yeah, today we'll be working on time series sales prediction. In our group, I have already shared an Excel data. By using that same data, we are going to do some predictions. We are going to learn time series sales prediction using that same data set that we have. It is provided by one of our friend, and we'll be using it. And this will be, obviously you all know this will be a 3-hour class, and we'll be running classification, regression forecasting, and deep learning, few concepts related to that, because the next topics in the next classes will be completely diving into deep learning. I'll give you a gist of it in this particular class and tomorrow's class as well. I'll give you some time, like take 2 minutes of time before I start. Look at the data set. If any one of you have never looked at the data set that I've shared, please open it once and just put it on your screen and have a look at it. Like what it is, what are the columns it have. I'm going to explain the data, like what it has and all. But before that, you yourself also once take a look. And we will be using Python, Pandas, scikit-learn, XGBoost. I'll talk about what is XGBoost, LSTM, and obviously our Google Colab. And this is how I have divided the class into. We'll be seeing what is time series. Then we'll be exploring the data. We'll be seeing the data set. We'll be doing data cleaning. We'll be doing feature engineering, like finding out the right columns. We'll be using classification to predict a low, medium, and high sales day, which day it has and all. We'll be doing some regression and forecasting. We'll be whatever the model that we have generated and whatever the metrics we got, we'll be doing some hyperparameter tuning to correct the model and to make it better. Then we'll do a 12-month future forecast. We'll be doing it from May 2026 to April 2027. We're gonna do a forecast on every month, and see and compare. There is no way to compare. We have to wait till April 2027. But yeah, we can at least provide prediction out of the actual values. And yeah, there will be a bonus as well at the end. I'll be introducing you with a little bit of deep learning, which will be completely covered in the coming classes, probably next week. But just I'll give you a gist of it. Oh. Okay, one of our friend has joined. So just like a recap, we have just started. In today's class we'll be learning about time series sales prediction. I have shared the data set that we are going to use, and by using the data set, we'll be predicting the next 12 months sales for that particular data set. Mm,
Thank you, Monesh. Thank you for the recap.
yeah, thank you. And yeah, so by the end of this class, you will have seen the full pipeline: understanding business problem, exploring data, cleaning it, engineering features, building classification, regression models, tuning them, forecasting the future, and even looking at LSTM as a deep learning bonus that I'm going to talk about at the end. And this class is based on daily sales records it is there in the dataset that I've shared. It will be from Jan 2024 to April 2026, and it contains around 833 rows, and 10 columns. Yeah, 10 columns, I guess. 10 columns. The columns include different payment channels. Like, actually, let me open it to you.
Monesh,
Yeah.
can you send the data again? Because I think since I joined late, I don't see it in the chat.
I shared it in our WhatsApp group.
Okay, okay. Thank you. Sorry, I didn't see that then.
Yeah. Yeah, this is the data set that I'm talking about. We have 833 rows. 834. One is the header. We don't usually count the header thing. So 834 minus the header, which is the first row, we get 833 rows, 833 actual rows, and we have 1 2 3 4 5 6 7 8 9 10 rows. So sorry, 10 columns. The columns include different payment channels like card, cash, DD, UE, GH, catering, total gross sale, um, and we have the main target, the total gross sale, the J column is actually our main target variable throughout the project. So this is going to be your target, and these are going to be your features. Next, and timing plan, as I already discussed. um, this is a 3-hour class. First I'll explain in this order. Mm, and before I start this class, I just want to tell you one thing, is that this class is not going to be a coding class. uh, Already, whatever the project, whatever the data set that we need to work, I have already worked. This past week I was doing the same thing. Whenever I get time, I was looking at the data, I was coding in Google Colab, and I prepared the entire project. It has nearly let me check how many cells it has. I think it has 60 cells around. If I code that 60 cells in front of you, I mean, whatever I have done the coding part, if I code it again in front of you while sharing the screen, it takes another 3-4 classes for coding that 60 cells. Instead, what I do, I already have coded the entire thing. We will be doing the decision making in this class. More than coding, it will be a decision making class. At every step, we'll be asking what this data is telling us, what assumptions are we making, what mistakes are we trying to avoid. These kind of things we'll be dealing more into, and also I'll be copy pasting the code. Whatever the code that I have already done, which you are not seeing in the screen, I have it in one of the folders, but I have already done. I have seen the output, I have seen the metrics and all. I'll just copy paste into the Google Colab to save time. If anyone doesn't like it, please let me know. I will do the live coding. I'll just type the same code in front of you. But if you're okay with it, we'll continue like that. If anyone is not okay with it, with copy pasting that code that I have already done, please let me know. I'll do the live one. And
Monesh, sorry to. I didn't see it on the WhatsApp. Did you send the Excel sheet for the time series or?
maybe let me show. Oh yeah, sorry. I think I did not hit send. I'm sending now.
Okay, thank you. No.
Yeah, thank you.
Yeah.
Let me send it quickly. I'm just stopping the share. Yeah, thanks, Komla. I've sent it now. Have you received it?
I was muted my microphone. Yes, I will receive it.
Yeah,
Thank you.
thanks, Komla, for that stuff. Yeah, please take some time to look over the data set that I've shared. Mm, and anything more that I'm missing before I start? Okay. So, what category is this problem? That is the first question that has to come to our mind. Whenever we look at a use case, whenever we look at the data set, the first question that has to come to our mind is that what category is this problem belonging to? This is a great place to explain like where this series fit in the machine learning landscape. Whenever I was talking about the classification or the regression or anything that I was teaching in the previous classes, I've never mentioned a time series in any of the places. There is a reason for it. Time series is not a one single task. You cannot just categorize time series into, yeah, this is classification, this is regression. You cannot do it. I'll tell you why. It can contain classification, it can contain regression and forecasting depending on the target we define.
శివాని
Based on the yes.
ఇప్పుడు ఒక అబ్బాయి వస్తాడు అశ్విత్ అని
So sorry. Did someone talk to me? I think no. Oh, maybe it's like the microphone maybe on. Yeah. Okay, so where am I? Yeah. It can contain classification, regression, and forecasting depending on the target we define. In this particular project, we actually do ML tasks. First, classification. Like coming to this stratification, we'll just first categorize the problem. The question that you have to ask in the classification is, can we predict whether a day will be low, medium, or high sales day? Whether this particular day, like let's say April 2020, April 26th of 2026 will be my highest sales or medium sales or low sales. If you're predicting in this order, then it becomes classification. If you're predicting the actual exact sales value, then it becomes regression and forecasting. Can we predict exact sales values, especially monthly sales, into the future? So the same data set that we have, it supports both classification, regression, and forecasting. Yeah. Any doubts, anyone in this? Like why it is classification, regression, and forecasting? Forecasting means predicting to the future. When you're predicting to the future in a timely basis, like for 12 months or 6 months or 1 month, then we call it as forecasting. So this data set supports multiple problem types. It cannot be just categorized into one single thing. It can be categorized into many things. Yeah. And yeah. So time series is more like a setting than a single algorithm. The setting is the time order matters. Once time order matters, train splitting changes everything. If every code that we are gonna do today, you're gonna see some differences. It's not going to be like a traditional ML project. There are going to be few changes here and there. Yeah, the setting is again that time order matters, train splitting changes, feature engineering changes, and leakage becomes a much bigger risk here. You have to be very careful with the leakage when handling this kind of problems. Yeah. Okay, coming to the dataset overview. I already told about the dataset. We have 833 daily records, 10 columns, date, year, month, cash, card, DD, UE, GH, catering, gross sale. The data runs from 2024 January 1st to 2026 April 12th. Gross sale is the total daily revenue. Like I'll be going through columns. Yeah. Gross sale is the total daily revenue, and the other payment channels help explain where that revenue came from, like whether it is cash, a card, or DD, or UE, or GH kind of thing. Card is complete. Yeah, card is complete across all 833 rows, while cash and catering have many missing values. That is what I've observed. When I observed the entire 833 rows, which I've done in the weekdays, what I've observed is card is complete data is there for card, but for cash and catering, they have many missing values, which at first might look like poor data quality, but in the business context, when you're talking about a technical perspective, you may think that this data is missing few things and it is a bad data. But if you think of a business context, they often just means zero sales for that particular channel on the day. Maybe a customer came and he paid by using card and he did not pay anything by using cash, which is absolutely fine. So in a business context, this is completely natural. But in a technical point of view, it may seem like it is bad data, but in fact it is not. And missing does not always mean broken. You have to remember this one line. Missing does not always mean that something is broken. Sometimes missing means none. None means zero. Nothing happened in that particular channel on that particular day. In business data, understanding the meaning of missing values is often more important than the act of filming them. Sorry, not filming. The act of filling them. Yeah. So in this scenario, I don't really think you need to apply a very big algorithms to fill those missing values. We doesn't require for this kind of business perspective. So I think it's not required for this. Now let's go to Google Colab. Yeah. Till here, any doubts, anyone? And some of the things that I have observed while looking at the code, I have mentioned them here. Like what is the average dial sell for that particular business. This is for me, this is not for you. I just put as a point for myself. And these are the missing values that I found when I using regional dot sum. Cash 61.7% they're missing, catering is 53, GH is 9, card and cross sell they're complete, which shows that it's a good data, because for business perspective these two are important. And this is the first 5 rows. Actually, I missed out 2 rows at the bottom. These are the first 3 that I've put here. Okay.
Monesh, I have a question.
Yeah.
So is it more of like learning is how to handle the time series data and how we build the end-to-end pipeline? Is the whole class today about that?
Yes.
Or okay. Just making sure I'm following that.
Sorry, Kamla. Or what you're saying next?
Yeah, no, that is that the reason like how we handle the time series data. And
Yes.
so the whole class is going to be like how you can build the models for the time series data.
Yeah, yes.
Okay.
Like how the
Thank you.
pipeline works. Actually,
Okay.
this why I introduced time series right now is because one of our friend, he is
Okay.
working on this sales data set.
Okay.
Yeah, so whatever the data set that we see, it is real, but some fabrication to the sales.
Okay. No, it's great because I've been coming across some of the people asking for like how do you handle the time series data and also which is nice.
Yeah.
Okay. Thank you.
Thank you. Okay, so let's start with our code part. Since we understood the data, how the data looks like, what are the columns, what are the rows, what are the missing values, how much is what are the ways that we can handle the data. Once everything, all of this plan gets completed, then we start with the actual code part. Okay, again, you all already know about this, but just like a recap, since many days has been passed, Google Colab already includes pandas, numpy, matplotlib, seaborn, scikit-learn. But when you're doing it in local, you need to install all of this. If you don't install, you cannot code. But in Google Colab, whatever the libraries that I've just mentioned now, you don't need to install them. But this particular project, we are gonna use few extra libraries like OpenPy, Excel, Missing No, XGBoost, and also something called Profit. We are gonna use this for each of these plays a different role. Like one is for Excel reading. If you remember till now, whatever the projects we have done, they all are in CSV. I have shown you how to read the CSV from pandas and all, but I never got a chance to show you Excel SX. That is your Excel, proper Excel. So I'll be showing you how to do the Excel reading, missing data visualization, boosted trees, time series forecasting. And for that, we'll be using this extra libraries. Um, and usually I say, right, don't just memorize the libraries, learn what job each one does. Instead of you remembering the libraries, it would be better if you remember what those libraries do. Like pandas manages the data, seaborn and matplotlib visualizes it, scikit-learn handles most of classical ml, xgboost is for high performing boosted trees. When talking about the trees algorithm, I'll talk about xgboost. And profit is for forecasting. PROPHET. It is for forecasting. TensorFlow and Keras also I'll be introducing today or probably in the next class, which belongs to deep learning concepts. And they come later at the end of the class, where I'll be showing you something called LSTM, which is one of the time series deep learning concept. When talking about it, I'll talk about TensorFlow and Keras. Let's copy this code. Again, whatever the code that we are going to do today, I already have done it. There is a separate file that I have in my local system, and I'll be just copy pasting today. I'll not be writing code. Usually I do the live coding in front of you, where we get the errors and I solve it and I show you the output and all. But if I take the same route, this same class is gonna take 4 extra classes. It would be a complete waste of time is what I felt. But if anyone else against it, or if anyone likes live coding, let me know and I'll do it. Since I already have done it, it would be easier for me to live code again. Yeah. So this line, the first line that I have written here, this not of pip install q is nothing but it will check for our environment. If OpenPyXL missing no XGBoost and profit, if it is already present, if it is already installed. In any case, if any one of them are not installed, then only pip install runs and it gets installed into the environment. That is why we have put this not symbol at the beginning.
Manish, we are not seeing your screen.
Oh, sorry.
And Monish, do you mind sharing the collab link too?
Oh, yeah, yes.
Thank you.
Anyhow. Yeah. So the not that we are using in the beginning, it is used to just check if these libraries are already installed. If they are not installed, then they get installed into the environment. And I almost every time say that change runtime type to GPU. And I've imported all the important libraries that I'm going to use in today's project. And this import warnings is nothing but for few things that we are going to do today. Oh yeah, I'm sharing the screen, right? Yeah. For few things that we are going to do today, from what I've experienced when I'm doing this project before, there were few warnings, and that warnings are overwriting the outputs. So for that, to solve that, I have written this line here: import warnings, warning dot filter warnings ignore. If anything that is ignorable, we don't show it. If anything that is an error, then only we show it. And for Seaborn, I have put a theme like my white background should be white grid and palette should be a muted. This is a format, a theme format that I'll be using so that output looks good. And here itself, I'm putting the figure size to be 14,5. Again, when I've done the project, these are the things that I wanted to do it in the beginning so that the output looks clean and neat when I'm showing it to you. Let's run the first one. Yeah, all libraries are imported. And I have also mentioned each one of them, like what it does here. I'll also share this presentation at the end. Okay, loading and inspecting the data. Usually, you can just click on the files here. You can click on the upload and you upload the file. That is one way. But in the last class itself, I've shown you there is one more simpler path where you can just there will be an upload button and you can just do the upload. There are different ways to do it. This is one of the way. I just click on run. It will ask me to choose a file. I click on choose file. This is the file salesexcel.sx and I upload it. It starts to read. So here it has read that the particular data set has 833 rows, 10 columns, and this is the columns. Okay, this seems good. Yeah, you already have know about all these things, like what is head, tail, info, and describe. The info output tells us the data types and the numbers of non-null values. The describe output shows us the numerical ranges, including mean gross sale of some 3,148 around. Here 3,148 something, and max gross sale of some 11052, which suggests there are some much bigger days than average. In the sense, what I'm trying to say is some days it has the sales are exceptionally good than the when compared to the average. So this immediately shows us that by doing this dot describe. Uh, Again, inspection is optional. Some engineers often want to jump straight into models, but first few comments already tell us where the problems and opportunities are. That is why we do all this head, detail, info, and describe. Next, the next part is EDA. Yeah, any doubts, anyone till here? And additional information I have written it on the right side for you. So just take a look when I send the presentation. Any doubts when moving to the section 2? I'm moving a bit quicker because we have already spent a lot of time on loading the data set, cleaning the data set, exploring the data set in earlier projects. So that is the main reason for these parts, these sections, I'm moving a bit quicker so that I get to spend more time on the important ones. Any doubts, anything till here? Okay. Yeah. Next is the next phase is exploratory data analysis. EDA. We call it EDA. EDA means exploratory data analysis. We visualize before we model. In this notebook, the EDA focuses on the missing value pattern, the daily trend, the monthly totals, and also the day of week behavior, distributions, correlation heat map. We are gonna see all of this. One of the strongest findings is when I looked at the data, which I've already done, one of the strongest findings that I have found is that card has the highest correlation with gross sales. When the card is higher, gross sales is higher. At about and the correlation, if I remember, it is around 0.79. The relation. The stronger the correlation, the stronger the relation. If I increase, they also increase. That is what correlation says. If I increase, result also increases. If I decrease, result also decreases. That is what correlation means. Card is directly proportional to gross sale. Catering is directly proportional to cross sell. If card increased, gross sale increased. If catering increased, gross sale increased. And you can see the correlation percentage here, how correlated they are. The larger the correlation, the better the relationship. So by looking at this correlation, that immediately tells us card is the main revenue driver in this entire data set. Card is the main important feature, main revenue driver in this entire data set. We are asking things like, is there growth over time? I mean, once we get the output right, we will be asking questions to ourselves like, is there growth over time? Is there weekly seasonality? Which channel matters most? These questions directly shape the features we gonna build later. Again, whatever we do, always put society and business aspect in mind, because you cannot for now you can argue that card is the best revenue driver here, but there might be a scenario where suddenly the entire online card transactions may fail in the restaurant, let's say, example, just an example. And for 1 month, let's say the entire card transactions are failing because of bank being froze or something like that. Then the restaurant has to completely dive into cash or DD or something else. So at that point of view, the cash will be the main driving force in that particular month. So you also have to take all these things into considerations as well when you're looking at the columns and the data set and the correlations. Let's do some EDA now, the code part, I mean. So I'll see the count values per column in percentage. So date, nothing missing. Cash, there are 514 missing. 61% of the data is missing. Catering, 53.7. That's fine. So this is for the EDA, that we are going to start our EDA, the exploratory data analysis. Date range is from 2024 1/1, 2026 4/12. Total days 833 days in between. Let me draw you a missing value heat map. Again, the code that I'm giving here, you will be using it later in different projects. That's why I'm using different plots to show you. This is one of the way to show the missing values. This is one of the neat way that I feel. You can see that there are missing values in the cache. There are missing values in GH somewhere here and here. In catering, there are missing values all over the data. In cache, in the beginning, if you observe, in the beginning there is cache data. Slowly the trend has changed. They started to get missing values in between, and suddenly, I don't know why, in the months, in the middle of the months, there is lot of cash, some or the other kind of cash, whether it is $1 or $2 or $8 something. There is some or the other kind of cash. I don't know what happened in these months, but there is some cash flow, some or the other kind of cash flow, and suddenly there is nothing at all for a few months. There is no cash at all, and again at the end there is nothing. There's completely gone, and slowly at the end again a little bit of cash started. So you, like this, you can use this heat map to understand visually where it has started, with which time it has gone and all. Catering is like throughout the months, every single day there is something or the other. You can understand in this manner. This is the first row, it goes to 833 rows. Next, I'll show you daily gross sale over time. So this is how our sales looked like. Why dates is not defined? Did I forgot to import something? Oh yeah, the error is gone. I just forgot to import templates. So yeah, you can visually see how um, our sales are. This red line is the mean, and this is our actual sales. So for example, October 2024 in the beginning, no, and in July 2024 at the end, the sales were highest here, around more than it cost 10,000 per day, and the highest is in middle of October 2025. Not October, I think it's October, November, December. Around November, I think it is the highest sales. So this is another visualization that you can see. When if you want to show any visualization over the months or over the weeks or over the days, dates, or anything that you want to show over the dates, this is what you will be using. This type of maps will be better to show. Next, I'll show you monthly total sales bar chart. Yeah, this is monthly total sales bar chart. So here also you can visually see when were the highest. April, May, June. So May was highest. October, November is highest. Something happened in May and November that have driven the sales a lot. And this is the combination of a month. We are not doing it weekly. Here you can look at daily, like whatever the weeks or days or that we have, you can look the in between patterns, but this is a bar chart, and this is a combination, the sum of the entire month. So for the total month, these are the sales. For total October, these are the sales. November is the highest driving point, and May is the highest driving point. Yeah, so you can observe which months are doing the best of 2025, but which may not be the case in oh yeah, May here has done 93K for 2024, and in November has again outperformed itself 97K. I think November is the best month then in the restaurant business, I guess. I'm not sure into it, but yeah, it seems that October, November, in between these two always perform the highest. Yeah, consistently, that too. That is what you can understand from this. Next, sales by day of week. This is the average gross sale by day of week. Like in total, in an average, every if you take every single day, if you do summation of all of it, Mondays usually the average sales were this much, Tuesdays were this much, Wednesdays, Thursdays, Fridays, Saturday, and Sunday. So usually people, I mean, from the data set that we have collected, we can easily understand that Fridays and Saturdays were the best times to drive the restaurant, and Sundays is the third highest. These 3 days, the revenue generated is high on an average on the daily basis. So every Friday, every Saturday, every Sunday, the sales were good. They're high, as better than Monday, Tuesday, and Wednesday, Thursday. Now, you can ask me like, Monesh, why are you showing me these many plots? Why these all are required? These all are required. All the plots that I am showing you, these are all are required because there is some concept called storytelling, which I'm gonna take a separate class to you. Uh, Whatever the outputs that you get, whatever the it's predictions is not the right word. Um, Whatever the things that you infer from the outputs, you have to present it to the clients, you have to present it to the management team, and management team doesn't see this code part. They don't even like to look at the code part. They only like to look at the visualization part. You show the management team this visualization and you explain whatever I'm explaining to you. You show this visualization and you explain the same thing what I'm explaining to you. So that is how it works. That is why I'm showing you a lot of visualization in time series, especially. Whenever you are working on time series problems, visualizations are very, very, very important. You generate as many visualizations as possible, no matter as many visualizations as possible in time series. First of all, it tells more story to you as an engineer, and it also helps management team also to make the right decisions. And this is a box plot which is by month. Here I've shown you by week, right? Now I'm going to show you by month again. By month. Monesh, here also it is month. This is also month, right? Jan, February, March, April. This is also monthly. And this is also monthly. Monesh, then why are you doing two different things, Monesh? Here you are doing with bar chart, but here you are doing with box plot. What is the difference? Why are you using two different plots for it? Here, whenever you're seeing a bar chart, your entire interpretation goes only to the sales point of view, like 95k, 92k, 93k, 91k, 87k. But by just looking at this bar plot, can you tell me on April what is the lowest and what is the highest? I mean, in April month, which day has the lowest? What is the lowest you got in April month and what is the highest you got in the April month? Like which sales? What is the lowest sales in your April month and the highest sales in your April month? What is the mean of your mean of the sales of gross revenue in the April month? What is the mean of it? Are there any outliers? To answer all of these questions, you cannot simply use a bar chart. You have to go for a box plot. What box plot tells you is, box plot gives you the minimum. You see, the lines that start here, they are not exactly in the same line. This is somewhere on the top, this is at the bottom, this is at the bottom, somewhere. It is going up and down, right? By looking at the box plot, you can see the lowest, the highest, the outliers, the minimum, the standard deviation. All of that is just covered in one single box plot. So that is why we use box plot. Box plot, I mean, I also written it in the comments here. Box plot shows medians, spread, outliers for each month. Whereas bar chart doesn't show you that. Bar chart is much more simpler. And the next is correlation heat map. Correlation heat maps, as I said, that is here. It talks about the relationship between different columns. The relationship between different columns. Card and cash has 0.05 correlation. It means little, a very small correlation. If card increases, there is no saying that cash also increases. No, we cannot do like that. If card increases, what is increasing? What is the highest here? 0.08. Gross sale is increasing. So you can think like that. This is the correlation map where 1 is the highest, -1 is the lowest. In any negative values that you see are the opposite of correlation. And in the sense they're instead of directly dependent, they're reverse. If this increases, that decreases. If catering is increasing, cash decreases. That is what minus says. If UE increases, cash decreases. That is what minus says. You see 0.79 and 0.65. Gross sale is correlated to card. Gross sale, it is correlated to catering because they are highest values. More the correlation, more the relationship, more the bonding. More directly dependent, more directly proportional. If I increase, you increase. If I decrease, you decrease. And histograms. Next plot that I want to show you is histograms plot. Again, the code will remain the same. I have designed the entire code in such a way. Usually for this particular project, we can write the same code in 2 to 3 lines, but I have wantedly have written it in a different way so that you change the columns, you edit these values to a different data set, and the code will work. You can use the same code for any project, any time series project. I have designed the code in such a way, in such that way. Next is histograms. Histograms talks about the frequency of the frequency of card data, cash, DD, catering, GHUV, and all different payment channels that we have. So the most card payments that we had were 1000 somewhere here, between 1000 and 2000. That's what I wanted to say. The cash, the amount between 1000 and 2000 were the highest card payments. They are the highest card payments. What is the highest amount that we got? Is 0. It is 0. Nulls are more. That's why we got 0 to be the highest. The second highest is maybe $1 or $2 or something, pounds or something. In DD, the highest frequency is again 220 somewhere here. This is the highest frequency. Frequency means count. How many times? That is called frequency. And here I mentioned few things. Whenever you are looking at histograms, right? If it is a normal bell curve, I have already shown you what is a bell curve. It starts, if any one of you have forgot what is a bell curve, I'll show you one more time. This is a bell curve. If any of the histograms show a bell curve, then it is a very good algorithm. Good for any algorithm. That histogram is good for any algorithm. If it is skewed right in the sense the amount of data will be on the right side. This is skewed left. This is also left, this is also left, this is also left. Right means in the starting there will be no data, and the ending there will be more data. I'll show you that as well. Bell curve skewed right. Yeah, you can see from this. Yeah, if left side, if it goes exponentially to the top, and just if it drives down, it is positively skewed. If it goes less in the beginning, like if it is slowly, if it is increasing in the beginning and suddenly if it drops down, then it is negatively skewed. So positively skewed and negatively skewed. And left right, you can see here. Yeah, this is a good representation. Left skewed distribution, right skewed distribution. Left means negative. Oh, where is that again? Yeah, negatively skewed is the negative one. Left is the negatively skewed. Right is the positively skewed. So whatever that we have here, which is increasing in the first and then decreasing, these all shows positivity. These all shows positively skewed, which is a right skewed right, which should be where the data will happen mostly on the left side, left part of the screen. Right part of the screen, then it will be negatively skewed. So yeah, by looking all of these charts till now, what I have interpreted is card is by far the largest revenue driver and most consistent. Catering has the highest single day values when it occurs, uh, around 7,150 around. There is a clear weekly cycle. Weekends and certain days are busier. Weekends are very busier. Seasonal patterns also exist that I've shown you, like few months, some months consistently outperform others, like your October, November, April, May. They're very good. They're very good months. These observations directly inform which features we'll be engineering in the next section. So yeah, any doubts still here? Till here, any doubts? Anyone? Okay. And where is that AI thing? Yeah, if no doubts, then yeah. But yeah, if any doubts, please let me know. And yeah, when looking at the code also, when you're having free time, if any of the graph you didn't understand or if any of the code you have not understand, also please let me know. Okay, the next step is data cleaning. Data cleaning is nothing but if there is any garbage in the data, we'll be throwing that garbage outside. And I'll be using different functions that I have all mentioned here, what each one does. So let's copy this code. And whenever you're doing data cleaning, always you have to work on the copy, never work on the original. Raw data should always be preserved, remember it. Never clean the data on the original data set. I'm neatly written what each step we are doing. Usually the same whatever the data cleaning steps that we performed on other projects, I have used the same steps. Nothing new. Yeah, after cleaning the data, you see instead of the null values, I have put zeros now. 0, 0, 0, 0, 0, 0, 0. And here also 0, 0. Wherever there are null values, I have put 0. I compensated them with 0, which is null. Because algorithms don't like null values. Instead of null, just put some integer, 0 or something. Next is feature engineering. Okay. Again, always feature engineering is one of the most important in the whole project, in the whole class that we have. Raw columns are rarely the best representation for ML. We create calendar features such as day of week, day of month, weekend flag, month, quarter, week of year and year. By using just a date column, we can create all these different columns. It is possible to do that, and this is the code on how we will be doing it. Then we create cyclic encodings with sine and cosine. You heard about sine and cosine, right, in mathematics? By using that sine and cosine, we can do something called cyclical encoding. Again, these all are bit advanced topics, but I wanted to give you a complete code, a project code that you can use for any different project. So that is why I have included all of this. If you don't want, this is optional. You do it or you don't do it, it's okay. But using cyclical encoding in time series is a very good thing to do. And if a recruiter of anyone sees this code, right, this small bunch of code that you have written here, immediately they'll come to know that you are very well trained in ML when you are doing a cyclical encoding by using sine and cosine, especially in creating feature engineering columns for time series. So we do this, and then we lag the features like 1, 7, 14, and 30-day lag. Then rolling statistics such as 7-day and 30-day means standard deviations that I have mentioned at the bottom. And weekends, there will be a flag to say it is weekend and all. We also create, as I said, we also create binary flags such as has cache, has gh, has scattering, plus an interaction feature called catering weekend. After dropping rows with the nans caused by lags and rolling windows, we end up with 803 rows. We remove some of the rows which doesn't give any value to our target and all. We remove them, which caused by the lags and rolling windows. So after doing that, we will end up with 803 rows and 31 columns. We will be ending with 31 columns. I'll show you how we'll be ending with those many columns, because we'll be creating those many columns now. Columns will be drastically increased now. From 10 columns to we'll be going to 31 columns. And this is how we translate business intuition into machine readable signals. Like features are how we teach the model what matters. So we will be making the features in such a way that model understands it better. And before going to the code part, the cyclic encoding. What is cyclic encoding? What is the sine and cos, Monish? What are you bringing suddenly? What is the sine thing and cos? So monthly numbers from 1 to 12 are not truly linear. Month numbers from 1 to 12 are not truly linear. December and January are adjacent in time, but numerically they are 12 and 1. What I'm trying to say is, when you count months, right, how do you count? January is 1, February is 2, March is 3, winter is 4, so on, right? You go till December. So from January to December, you are in an increased line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. But suddenly, when you're going from December to January, you're going from 12 to 1. You're going from 12 to 1 immediately. There is no slope or nothing like that. Immediately you're going from 12 to 1. I think screen share stopped. Let me reshare. Yeah, what I'm saying? Yeah, but numerically they are 12 and 1, which look far apart. So sine and cosine encoding map months onto a circle. They make this 1 to 12 into a circle. So the model understands seasonality properly. If you don't do this cyclic encoding, right, once it hits December of 2024, then when it goes to January of 2025, suddenly the model won't understand anything. Because still now it is 12. After 12, what should come? 13. But again, you are giving 1 for January. The model won't understand. Your model is like a child. Again, I'm saying your model is just a child. The model won't understand from 12 why you suddenly went to 1. But if you do sine encoding and cos encoding, right, it becomes a circle. It becomes a circle. So after 12, when you again provide 1, that is January, the model understands this time. So that is why we do cyclic encoding and cyclical encoding. And many of the projects that I have seen in the internet, they lack this feature. They lack this cyclical encoding. Cyclical encoding is one of the important concepts in time series. If you go for an interview and if the interviewer is asking about time series, 90% of the chance he will be bringing up this cyclical encoding, whether if you know it or not. So now after this you should know what is cyclical encoding. Cyclical encoding is introduced because after December, when we go to January, it suddenly becomes from 12 to 1, which the model will not understand. So to make the model understand, we create that maps into a circle. To create that map months into a circle, we use something called cyclical encoding, which creates a cycle, which creates a circle. Yeah, if we leave month as 1 to 12, the model thinks December and January are far apart. With the cyclical encoding, it understands that calendar, it's just calendar wrapping around, like next year is starting. This usually this usually makes it things much more easier for the model. And this is how the values will be changed. Month number 1 will be changed to 0.50. Month cost will be changed to 0.87. Again, as a human, you will not understand what is this, but they understand, but model understands. You see 0.501, 0.00, minus 1, minus 0.050. You will not understand as a human, but model understands the what is going on here, that a cycle is being created. You see 0.502 minus 0.50. 0.87, 0.87. In between, there is minus 1. So model understands it better than you, than a human. Any doubts still here till cyclical encoding? Again, I understand today's class may be a bit complex. Take your time. These concepts are something you will not understand immediately, but the code that I'm providing is a very big, easier code that you can work on any project. Take your time. Take even this weekdays and all. Anytime you have a doubt, let's say Wednesday, in your time, night 11 o'clock, you have a doubt. Like for example, Monish, what is this np.cost, what it is doing in this line? Immediately put a message to me. Whenever I look at the message, I'll give a reply back. Yeah, so after doing all of this, you can see the rows are now 803, but the features are 31. There are 31 columns now. 31 columns. Where we started with 10 columns. We started with only 10 columns, but now we are in 31 columns. Usually this is not how I teach. Like I usually go only slow. I would have shown you only how to create 13 columns or 15 columns, but since it's a real data and one of our friend is really interested in the next predictions, I really went to everything in it. So I just made changes like 10 columns to 31 columns. The better the features, the better the model. Accuracy may be low. This is one more drawback. Since I'm converting this 10 to 31, right? The accuracy may be low, but even if it is like 60 accuracy or 70 accuracy, we can trust it. We can trust that accuracy even if it is 60, 70 in this kind of scenarios. Def feet is not defined. Oh, I did not run the top one. Yeah, you can see here, these are the new columns that we have. Cash to gross sale, you already know the first 10. We have day of week, day of month, is weekend, month num, quarter, week of year, year, month sign, month cos, down sign, dow cos, lag 7, lag 14, lag 30, rolling 7, rolling 30, has cash, has GH, has Catherine weekend and all. Yeah. So this is how really we do it in companies. I'm not teaching you like how we teach to students and all. This is the real featuring that we do in companies, in real companies. When you go, this is how we do it. We create lags, we create rolling. Lag is nothing but lag for the first 7 days of a month, first 14 days of a month, first 30 days of a month. Rolling 7 means the standard deviation of the first 7 days. That is what rolling 7, rolling mean, more rolling 7 max mean. Again, I know this project is entire complex, but I wantedly made it very complex so that you will all be uploading this to your GitHub. You will be using this project as your one of the projects that you will be showing it to the recruiters. This is a very high complex projects that we have done till today in when compared to other classes. Other classes I made it very simpler. I could have gone more complex, but it is not required. I did not go. This project, I want you all to put it in your GitHubs. I want all of you to put it in your resumes. If you don't have a good project, you have to show this project to recruiters. If you don't have any better ones, show this. They'll come to understand like you have a lot of knowledge in ML and deep learning. Okay, yeah. Any doubts still here on like what is this cyclical encoding? What is feature engineering? Any doubts still here? I bet most of you are still confusing and taking into mind. And
Yeah, it's a lot. So
yeah,
trying to process.
I understand.
Yeah.
Yeah. Take your time. I'll just go over the entire project since this is a recording. But yeah, if any doubts, please let me know in any of the time.
Yeah,
I'm
I
not
think
discussing
that
anything.
sounds good because we can probably in the week kind of like go in detail.
Yeah. So the next step. So we have completed the deep dive. I'm deep dive in the sense EDA part, feature engineering part is done. And next we go to classification. Why are we going into classification? Because we have to go to the beginning again. Here, what I've told you, this particular problem comes under different categories. It comes under classification, it comes under regression, it comes under forecasting. So the next step should be classification, then regression, then forecasting. Okay. When we are talking about classification predict sales tier, the problem here we have to ask is what is the sales data. Here we have to ask a question: can we predict whether tomorrow, like let's say April 26th, will be my lowest sales, medium sales, or the highest sales? That is what we are trying to find. If you are categorizing your problem into low, medium, or high, then it becomes a classification problem. This is a multi-class classification problem. We define types by splitting gross sales into 3 equal frequency buckets: 33, 67th. Like 0 to 33 will be low, 0 to 33% will be low, 33 to 67% is medium, 67% to 100% sales are high. We will be dividing this into three parts, three parts to low, medium, and high. Why time based train test split? Here I have written it, time based split. Why, Monesh, till now you said like 80 20 20 80 60 40 something something. Now again, why are you coming and saying time based? In this kind of time series problems, unlike our random splits, we must split by time for time series data. you cannot do random split here. Till now, in the previous projects that whatever we have done, I have used rand 42, if you remember, for splitting. Now we can't do that. You cannot split randomly in a time series data. Very important. I have seen projects of different students and different my colleagues even, they're using random for time series split. You should never ever do random splits in time series. It should not. If we randomly split, we would train our future data to predict the past, which brings a big problem called data leakage, where you are already showcasing the feature and you're predicting the past now. That is a huge mistake of data leakage, and so that is the reason you should not randomly split in time series. This is one of the interview questions that happened to me when I was getting interviewed for the jobs as an ML engineer long back. This was the question that was asked to me on why on time. First of all, the question is whether in time series you can do random split rand 42. The answer is no, and the interviewer asked me for the reason. This is the reason. If you do a random split, there will be a data leakage problem where you will be training on the future to predict the past. And also there is one more rule: train on earlier dates, test on the later dates. Like since it is from 2024 to 2026, you have to take the training data from 2024 and 2025 and use that data to test it on 2026 data. That is how split should happen. And I also included lot of models into this. I've included logistic regression. You already know why. Simplest classification, simpler linear baseline, and I've included random forest because last project that we have done, random forest gave us good outcome, if you remember, like good accuracy. So I have again included random forest into this. And also I've used XGBoost. XGBoost, I've explained to you what XGBoost algorithm is in one of the previous classes, but I've never shown it to you. So that is the reason I brought XGBoost into this project. So logistic regression, random forest, and XGBoost. These are the three things we're gonna use for classification. And that is this code. So you can see here the lowest threshold is 2365 something, highest threshold is 3656. We have divided into low, medium, and high. 273 rows are medium, 265 rows are low, 265 rows are high. So total 713 training samples, not testing. Again, training is different, testing. Out of all the data, I have split 713 to be training, 90 to be testing. And out of the 31 features, I have used 24. In the 31 again, there are some important, some are not important. We have removed few and we are using 24 out of that. Next, we will be doing for logistic regression. Yeah, we are training for logistic regression. This is the same code, but I've made it such a way that you can use it for any project. Same code as the last one, I mean in the earlier classes. We will train all the classifiers now, all the models. This is just the preparation. We have not done any training. If you see here, I have never done any training here. This is where I'm scaling the features, encoding, one hot code encoding, the label encoder we used, right, in previous projects. I've used that here. This is the part where we'll be actually training them. See, logistic regression, fit. What we use, fit is for training. If you remember, fit is for training. Transform is for transforming. Here is where we are actually training the models. Logistic regression, random forest, XGBoost. And I have given few parameters for each one of them. training is happening. Yeah, all classifiers are trained. So classification training is done. Now let's look at their accuracies. The next step is evaluating. You always remember, once we do the training, the next step always is the evaluating. Yeah, so logistic regression we got 689, for random forest 644, for XGBoost this is 633. So out of all, logistic regression gives us the good accuracy. Now let's do confusion matrix. I already told you what is confusion matrix is used for in previous classes. Just to visualize this matrix, we use confusion matrix. Confusion matrix is not defined. And your Google Colab has this neat feature. Whenever you're having an error, right, just click on explain error. It will try to solve it. After solving it, you just have to click on accept and run. Yeah, it's solved. It's an import problem. It just imported confusion matrix again. So you just here you will be seeing the whatever that you have here. You will be seeing it visually. Again, if you give this to management team, they won't understand it. If you give this, they will understand it. By looking at the colors and all, they'll understand it much better than you providing like this. Same thing, whatever the data that you have here, it represents that same, but in visual aspect. Classification setup 3 classifiers is done. Yeah, I already mentioned the classification results here. As I said, I already have seen the outputs before. Linear logistic regression 68.9, random forest 64.4, XGBoost is 63.3. And one more thing I thought of actually telling at the end, this is how you present to the management team as well. This is how you present. I mean, you have to copy this visualizations and you have to paste it in this presentation, and you have to create a neat visual view with different colors, different bullet points and all, to showcase it to the management team. There is a class on storytelling, but I'm just giving an example, like how I'm teaching you, like I'm creating this neat visual aspects, right? No matter how you do, you use AI. I used AI to do this. I explained AI how I want, what colors to be used, and how I need, like how the logistic regression is to be shown, how random forest to be shown. Like for example, random forest, I picked green color. Yes, I wantonly have done that because forest is trees are usually green, so I picked green there. Like that, I try to play with colors here and there. XGBoost is the lowest out of all three, so I picked red there. Here I wanted to pick green, but I wanted to give forest to be green color, so I've given blue, which is a pleasant color, and it matches with the heat map that is here. So I've given this blue. So yeah, you can play with colors. I'll tell you in the story class how to do all of this. But this is how you present. You put the title, you put the regression values, you put this heat maps, you copy these heat maps, put it in your
No, no,
presentation.
don't give the names and things.
Sorry, Kumar.
Oops.
Okay, I felt someone was talking. Yeah. Sorry. So with bullet points, you'll be explaining them. So one last thing to end classification is, in classification, after you getting the metrics, after you visually showing it, you have to also understand the feature importance. Like which features does each tree model relied on the most, which made us understand the metrics better. You can get it here. So for random forest, the top 15 columns are here. For XGBoost, these are the top 15 columns. You see there is a difference. Random forest is taking lag 7 to be the most important column, whereas XGBoost is taking day of week as the most important column. That is what I was telling in the beginning. You cannot simply decide this column is good, this column is bad, this column is good for this algorithm and all. Every algorithm works different, and here random forest is thinking lag 7 is the best column, whereas XGBoost is thinking day of the week is the best column. So there will be some changes here and there when you're using different columns. Finally, you end this classification thing with a classification summary. That's not code. Sorry, that's you actually give something like this. This is the classification summary, like why logistic regression wins and what 69% actually means, and all. This is the summary part, results part. And I've just pasted here this table. Yeah. Till here, any doubts? I know. I cannot simply ask you like any doubts are there or not. But conceptual wise, on what we are doing, if anyone have any doubts, please let me know. Not into deep code and technical aspect, but on a conceptual level, if anyone have any doubts on what is happening here till now, please let me know before we go for break. Okay. Yeah, let's take a break then. After the break, classification part is done. As I said, we will be working on different types. In this, only classification is done. There is regression, there is forecasting. So after the class, I will be covering regression and forecasting. And also I'll be, if time permits, I'll be diving deep into deep learning. So yeah, let's take a 20-minute break and let's meet after the break. See you after the break. Yeah. So we have completed still classification. So now we have to start with the regression. So why these two different type of approaches? Yeah. So the data set has 800 plus daily records, like something 833 and all, but only has 27 monthly records. This creates a fundamental modeling choice. One is daily regression. Training samples will be 700 plus. That is a random forest and XGBoost. And monthly regression, 21 rows, linear regression, hard winters, profit. That I'll be showing. So tree-based models need hundreds of samples to avoid overfitting. With only 21 monthly rows, like random forest and XGBoost, would memorize the training data and fail completely on the test set. That's exactly what that is what the R square less than 0 will show you. I mean, in the output, you will see that. So let's start with daily sales regression. Okay. So we use the same 700 plus daily feature matrix from the section 5, the classification thing. Same X train, same X test. Here also same. We'll be using the same train on same test. and the only difference is the target. There it is there it is categorized gross sale, like low, medium and high. Here you will get the actual numbers, gross sale. Here we are more interested in the gross sale. So let's do that. Okay, see, daily regression train, we have taken 713 rows, 730 rows for the train. Test is 90 rows. Train data is from 2024 131 to 2026 112. From 113 to 2026 412, that will be our test data. We will be doing the regression evaluation, the training and the fit. Already training happened. R data like random forest fit, XGBoost fit, linear regression fit. Again, I'm saying I'm using linear regression for the regression, logistic regression for the classification. So let's evaluate the models now. Yeah. So these are the metrics that we have got: MAE, RMSE, MAPE, R². If you remember, I told you the more the R², the better the model performance. So 0.73 like 73%, 67, 61. So linear regression is the best model that we have here. What we did here, this is for this is for the entire training, daily gross sale. That is why we have this linear regression. Every day, how the sale is, we can see in this. Now let's do monthly regression. We aggregate daily, so monthly totals to build the forecast models. All the daily will be aggregating, will be creating a mean to create a monthly data set, monthly set for the 12-month forecast. What you see is daily. Again, I'm saying whatever the data that you're seeing here, whatever the values, the visualization part that you're seeing here, this is for daily. Now we'll be creating for the monthly, and these are the daily regression results on the last 90 days. Linear regression is best again with MA 50211, RMSC 648, MAP 1471, R² 0.73. Second best is random forest, third best is XGBoost. The important interpretation is that the best model explains about 73% of the day-to-day variance, our linear regression in sales, and is off by roughly $502 per day. I think that is fine. I think $502 per day when you are earning this much is fine. For noisy daily revenues data, that is quite good actually. What I feel is linear regression is the best one till now on what we have seen. If I asked you the same question in the beginning, if I asked you like what model would win, most probably I think you all would say XGBoost because of what I've explained in the algorithms class, that XGBoost has good parameters and gives good results. You would have guessed it as XGBoost, but in reality, linear regression won. Out of classification and out of this regression category, linear regression won the model race. We trust the evidence, not our assumptions as an ML engineer. So monthly regression setup. The next one is monthly regression setup. Now we change the level of analysis from daily to monthly. I'm sharing the screen, right? Yeah. So now we change the level of analysis from daily to monthly. The notebook resamples daily gross sale into monthly totals using month start frequency. So daily, how much you cannot see now. I will be adjusting the data to convert into monthly sales. like how I have shown it for bar charts. In the same way, I'll be categorizing it into monthlies now. It drops April 2026 because it is only a partial month. I will leave out the April 2026 this month, and leaving 27 completely on the monthly records, and I'll create a new one. It creates monthly features like month. I'll be using month number, year, quarter, month sign, and cosine, lag 1 to 3 months, and rolling. After dropping lag created NANs, only 21 monthly rows remain for the modeling. And what we are going to know, the code that I'm going to paste, this will be an excellent place to understand the data scarcity. On daily data, we had hundreds of rows. On daily data, we have hundreds of rows. On monthly data, we suddenly have 21 training ready rows. Monish, what are you talking about? Let me show you. This is our data now. Are you understanding my point, right? From this much of data, from 833 rows of data, now we have segregated it into this only 27. That's all we have now is 27 rows. That is how I segregated. This is for monthly regression. I've segregated our entire 833 into this 27 rows. So now we have to work only on this 27 rows that we have here. Leaving out April, I left out this month because this month still 31st did not come. So I have removed 2026 April and I have considered only till 2026 March. And gross sale is the total sales of that month. And here the modeling strategy also will change because of the sample sizes changing now. So we'll be doing the monthly sales. This is our data that we have, and I'm picked up the good features, good columns. So again, you have to do the test split because since the number of rows have changed, you cannot rely on xtrain and y test from the top. You have to redo the test split. So till 2026 January, previous dates have taken into train. After 2026 January, I have taken into test. So train months are 18, test months are 3. 80-20. Still this is 80-20. Now I start to train the models. Okay, monthly regression training is also done. Let's do also. I also wanted to show you one thing. I think this is the best place to, for example, I just want to show you how to understand something if you are not understanding. Here I have used profit, right? This is used usually for adjusting the R² values. For this, for example, if you have not understood this, Monish, how will I know? I'll ask you the doubts, but if I want to know on myself, then how will I come to know what happened here? You just click on this button and you will ask for explain code. It will understand it will look at the previous outcomes, and then it will try to explain you this code. Let's see what it says. Yeah, the code block implements perfect time series. First you prepare the training. Okay, it is telling me what it does, but I want to see. It did not explain exactly what is profit. So I'll ask the same question. Yeah, see, this is right. Whatever it is given here is right. So we use profit. This is a forecasting tool. Yeah, it's from Facebook. Whenever you are using time series data, especially with seasonal, like holidays or any missing data or any these kind of data will be there, right? And there will be a lot of outliers. There will be a lot of outliers as seen in the box plot. If you remember in the box plot, that's the main reason I've shown you box plot in the beginning. In the box plot, immediately observed there are a lot of outliers in September, November, and the December. December and November I can understand because it is some like there are usually holidays at the end of the months. Then I came to think like why there was a outlier in September, a very big outliers, but it did not happen in the previous years. But in September here and December there are constantly there were a few outliers. So for that I thought of using bringing profit into this. What profit does is it understands the seasonal components like holidays, missing data, if there are any special weekends and all, and it tries to adjust those values, it tries to adjust those outliers. uh, Automatically your data is first transformed into DS column, which is understood by profit, and then you can give some particular settings. It has few parameters here like seasonality mode, whether it is additive or not, yearly seasonality, weekly seasonality. Based on how you change these parameters, the outcome varies. Here you can also see what each parameter does. um, Again, this is very bit complex topic, usually people don't use this at all, but when I looked at the outliers, this immediately came to my mind to remove that, and I've used it. But yeah, if you I'm not going to go too deep into this because I have to explain a lot of other topics to teach you this profit, which you may or may not use at all in your life. But if any one of you are interested, whenever you are using time series, and if you see a lot of outliers, and if you're working on seasonal holidays aspect of the months or data, then you use profit to adjust those outliers. Yeah, take this as an assignment. Again, I'm not delving too deep into it because you may not even use it in your life at all, but I just thought of using it since there are outliers. Mm, yeah, evaluation, I did not take the evaluation yet. So training got completed on the top. I have also included profit to tune a few things. And now let's do the evaluation part. Let's also see for the profit thing. So total, we have used linear regression, random forest, XGBoost, Holt Winters, profit. 5 different regression models. And for the 5 regression models, these are your metrics. For 0.49 minus, 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 minus. So here is one of the strongest lessons in the whole notebook, in this entire whole notebook till now. With only 18 train months and 3 test months, linear regression is the only model. Linear regression is the only model with a positive R². I mean, with this much of less data, even first time when I was looking, even I was surprised. I thought all 5 will get negative values, but when I saw that linear regression still was able to get in the positive side, it really surprised me. Because the training data is less in the first place, test data is less in the first place, but still linear regression outperformed what I thought. Its MA is also very good, like 2475, which is fine. When you're earning this much, 2475 is so negligible. Random forest gets the second place of minus 1.03. XGBoost is minus 2.6 and minus 7.8. Profits minus 7.41. And negative R². I think till now we have never seen a negative R². And negative R² means the model is doing worse than just predicting the average every time. It is doing worse, very bad, because it's happening mainly because of the less trained data and test data. Here you will get a question. Wait, Monesh, pause for a second. Monesh, if you know that the values are negative, if you know that you are going to get very less bad models, why are you teaching me this profit? Why are you giving me the code for this halt winters, this code, this why are you giving me the code in the first place for monthly regressions and all? Again, I'm saying, if you're thinking of a project perspective, all this is not required. Our entire project ended here. It got ended here with this code. This is the last bit of the code. If you are really interested only in this particular project, only with this data set, only with this sales prediction, why I'm going ahead and why I'm giving you this monthly regression and engineering more monthly features, train split for monthly, using this new halt winters model and profit model is so that when you go for a different project with a very large monthly sales, like for example, you have 10 years of monthly sales. I'm not saying daily sales, 10 years of monthly sales, then this code will be useful. At that time, you will message me that this particular code is very useful for getting those accuracies. For this particular data set, it is bad. I agree. When I was coding, I know that it is going to be bad, but I was just introducing you all this code so that when you are going on bigger projects with bigger data, with a lot of 10 years of 10 months, 10 years of different months of data, then this code will be useful. Otherwise, for this project, it is not useful. So some of these more complex models are not just imperfect, they are actively worse than a naive baseline. The random forest is bad, XGBoost is bad, halt winters is bad, profit is bad. For this particular data set. For this particular data set, these algorithms are very, very bad. But if you take 10 years of months of data, suddenly you will see a rise in them. Suddenly this profit will be the highest accuracy. Second, you will see halt winters. Third, you will see XGBoost. Try with the long data, then you will come to understand what I'm saying. It should be at least 10 years. Take 10 years of data, do monthly, put this into this code, convert into monthly regression model, and run it. You'll come to see what I'm talking about. Linear regression will be less. All the other models will be, they will be giving you better R²s. Yeah, our accuracies. Monthly regression setup, as I said. Yeah. For this particular data set, linear regression outperformed very well. It outperformed so well. When I was coding, I really thought it should be a negative value. I mean, out of all this experience that I had, when I coding itself, I know some of the algorithms will give what values. I really thought it will be something around -2, sorry, minus 0 point something. But when I saw 0.49, even I was surprised. That's why I gave this small thing emoji. Yeah, it really outperformed itself. Best for small monthly data. Random forest, XGBoost, Halt Winters, Profit, as I imagined, they all were very bad for this small data. But when you go for a bigger data, they will outperform good. Again, the project has ended long back, but still, few more things are there. Till here, any doubts, anyone? Conceptual level, on a conceptual level. Any doubts, anyone? Again, Halt filters have not talked much. Halt filters is also one of the regression model, but it's not so popular. But I had to use it in one of the projects in the company, so I just put it here. Halt filters is also one of the same models like random forest and all, but it doesn't work on trees. It works on time series especially. Halt filters and profit are especially time series algorithms. The rest all are regression algorithms. Any doubts, anyone? Am I frying up your brain? Yeah. Okay. But yeah, once again, I'm saying the code that you're seeing here is uh, corporate level code. Like this is the same code you will be using inside the companies, not your personal projects. This is a very high level complex code that you are seeing, and it's a real code that we type, that we do in the projects. So once regression is classification is completed, regression is completed, forecasting is done. This is nothing but forecasting what we have done here. Next we have to do is the actual forecasting still happens. 12-month forecast still did not happen. I did not show you that. 12-month forecast will happen. Before doing that, we have to do something called hyperparameter tuning. Whatever parameters that you have used so far in the algorithms, now is your chance. If you want to correct any of it, now is your chance to tune it. We tune XGBoost using gridset CV with the time series split, and we will try combinations of n estimators, max step, and learning rate across 3 time aware folds. Uh, and the best hyperparameters I found are learning rate 0.03. I mean, without you knowing, I have tested lot of parameters on the model. I changed here and there. I tested what happens when this much is changed and all. I came to know few parameters which are good. I'll be adjusting now. So when the learning rate is 0.03, max depth is 4, estimate has to be 300 with the best cross validated MAE somewhere around 21,000, I guess. So 10,000 around. I think I mentioned all of them here. Anyways, I'll give you the code. Yeah, after doing all these adjustments, then I saw some betterment. So yeah, we will be doing the hyperparameter tuning. Oh yeah, actually I have to show you actual with prediction plot, which I forgot. Yeah, this is the actual versus predicted monthly sales. Black line is the actual sales. These are the predicted sales, different colors. Black is actual, blue is linear regression, yellow is random forest, green is XGBoost, violet is halt winters. And I also have to show you the residual plots. This is again the metrics that I've used on the top, but visualization part, visualization of the metrics. If it is positive, it is overfitted. If it is negative, it is underfitted. Now comes the actual tuning, fine tuning. So as I said, we will be tuning the XGBoost thing and some parameters. So it is fitting. Okay. So the best hyperparameters are, this is what we got. We are retraining the models with the new changes. XGBoost regressor dot fit. Again, we are retraining the XGBoost. Like this, you can do for different models. You can also do for random forest. You can also do for linear regression. You can also do for other algorithms. I'm only doing it for XGBoost for now. Okay. So fine tuning is also done. So completed. All the things that you can do is over. Now is the time we do the actual prediction. Till now, whatever you can do to get the predictions you have done. You have tried to train with different models. You have adjusted different parameters. You have seen the data. You have played with the data. All of this is done. Now is your final exam. Your preparation is completed, your mock exam is completed. Now we are going for the final test. This is your final test. You are going to generate the 12-month rolling forecast, predictions for the next 12 months for your business. That is this code. Whatever I have learned so far, I'm putting all of that here, and I'm going to do a forecast. I'm doing best xgb.predict. So the output of this will be your 12-month forecast. This is your output. So for May, I mean the next month, May 2026, this will be my predicted sales based on my past data. The lower bound, I mean the lowest that it can go is 10,000, I mean something 104k something 104k. The highest sales I can go is 104k 149. Monish, what is the use of predicting like this? This is how banks will give you loan. This is how banks will give you loan. This is the actual, I mean, I have worked with different financial sectors till now, different bank sectors, healthcare sectors I worked. And this is what actually happens when you are applying for a loan as a business person. That is the reason bank people will ask you for your past sheets, past sales, past how your business is and all. By using all your past data, there will be an engineering team in the bank. Your data will be sent to them. After sending, the engineer team will be using the same code that I have shown you. It will be, most of the code that I've given you will be the same. They're gonna run the data set on this code and they're going to generate your next sales. Until and unless there is a pandemic or there is a very big outlier or something social aspect, until that happens, this is how your sales is going to be, the prediction. Based on that, they will give you a loan. If your lower bound is too low, they might not give you a loan. If your lower bound is too low, like let's say if your lower bound is 5,000 or 10,000, they may not give you a loan. If your lower bound is good when compared to the predicted sales, probably 99% will be granted a loan. This is how it works. This is how banks work. This is the one use case that I can think of. Even as a business person, you can also use this code to predict your next purchases, whether you have to take a home or whether you have any things to purchase. you can blindly go and purchase them because your next sales looks good. Only in the February and only in the Jan 2027 and Feb 2027 the sales doesn't look good. Rest of the months it's fine. Yeah, rest of the months they're good. Only Jan February your business is going to see a little bit down phase. That is what we come to know about this prediction. But will managers understand this? No. So what you have to do, you have to draw a diagram. How you draw a diagram? This will be the code to draw your diagram. Yeah. So this is your historical monthly sales till now. And this will be your next sales from May. This is how your sales are going to look like. Jan 2027, Feb 2027, it's going to decrease. But again, it is going to be good. If you think you can use the same code on stocks as well. You take any company. Take the past company graph, give it to this code. The next graph will be generated. Even many of the stock websites that is making millions out there, they're using similar type of code. Even you attach this code to a website, you create a good website, stock website, use this code as the backend. By if you are doing right business things and all, then yeah, you can also earn millions out of it. This is the same type of code everyone uses. You get the same code, give the past 10 years of data of a company, it generates the next 10 years. Yeah, this is a 12-month forecast. Weakest month is Jan, strongest month is September, 12 months total average. Yeah, I don't think I'll start a deep learning today. I don't want to fry up your brain. Already it is more complex than expected. Yeah, I will end here. I'll stop here, and I'll start the next class with basics of deep learning. Yeah, I don't want to teach you these three now. So any doubts still here? This is done. The project is done. Please upload it to your GitHub. Please try the same code on a different data set. Monesh, how can I easily convert this project to a different data set? Very simple. Use AI. Go to ChatGPT, go to Gemini or anything. Upload this code. Download it using this download button. Download with IPYNB. Upload it back to ChatGPT or Gemini and give any data set that you like. Say any sales data set or car data set, stocks data set or anything. Small code changes only, like changing the column names and all. But the rest of the code remains the same. That AI will do those changes, column changes, and you can use this project with any data set. I already tried it. With a different data set I have. It worked. That is why I'm telling you. So yeah, any doubts still here? So today's class is one of the complex class till now. Yeah, take your time. That's why I'm even stopping here. We have still half an hour. Like next bonus deep learning, I wanted to talk, because this is what we usually do in the companies. Again, I'm saying whatever the class that I took today, the basis of this class is not to teach you time. I mean, it is to teach you time series, but not to feed you on a comfortable basis. When I thought of teaching this class, I had two options. One is to make comfortable code so that you will be looking at once, but that you cannot use that code anywhere. Time series is one of the important topics in ML. You cannot use this code in interview. You cannot use this. use the comfortable code that I thought of. You cannot use those comfortable codes anywhere. You cannot you upload it to GitHub, but it will be of no use. You cannot put it in your resume. In interview also, you cannot showcase that comfortable code that I thought of. So I picked up the harder phase, that is the complex code. You understanding this complex code will be harder. It will take some time. At least you will take 1 week of time. But once you come to understand this code, right, that's it. You are done with the time series. You can use this code in different projects. You can use this code with the different data sets. You can use this code in interviews. You can use this code in GitHub, showcasing in your resume as well. You can use this code even to make money. If you are able to generate a website, put it in Play Store and actual website, get the clients, you can actually make money out of it. So that's why I took the complex phase. It's harder for me even. It took me 1 week of time to do this entire code. Since I was doing my job and in the evenings I was doing this. Yeah, it's a bit complex one. But this is the real code that we use. So any doubts, anything till here? Anyone? Yeah, I know you need some time.
Yeah, no, thank you for doing this. I think I probably want to kind of go through during the week and maybe try on the different data sets.
Yeah, sure, Kumla.
Yeah.
Definitely you will.
Yeah.
Thank you then. Thank you everyone. Love you all. Take care. I'll see you all in the next class.
Thank you, Monesh.
Yeah.
Have a good one.
Bye.
Bye.
Thank you.